Okay, let's talk about units in equations in any kind of science class, physics, chemistry, biology. Any equation you have always has to be dimensionally consistent, meaning every term in the equation has to carry the same units. We can't have an equation that says meters equals seconds, or we can't even add meters and seconds. Remember, terms are the things that are added or subtracted. Factors are multiplied, terms are added. So it's like a really basic example. Consider distance equals rate times time. This equation has two terms. The left side's one term, the right side's another term. And both of those have to have the same units. So if D is measured in meters and T is measured in seconds, then R, the rate, has to be measured in meters per second. So if we were to write down, we're not plugging in numbers here, we're just plugging in our units. And I like to use these little braces here to indicate I'm plugging in units into an equation. So D is measured in meters, T is in seconds, R has to be meters per second so that the seconds will cancel out, leaving base units of meters on the right side. And then we have meters equals meters. That's allowed. So any equation you're going to have in your physics class, your chemistry class, any science class, every term is going to have the same units. So let's take a look at this example. So I want to check, is this equation here dimensionally consistent given all these units? My x's are going to be measured in meters. What we call V naught is measured in meters per second. T is in seconds. And A is measured in meters per second. So I have four terms altogether. X here is a term. X naught's a term. V naught times T is one term. And 1/2 AT squared is one term. Now the 1/2 doesn't carry any units with it. I'm not worried about that. I'm not plugging in numbers. I'm plugging in my units to see if all four of these terms will end up with the same units. So I plug everything in. The x's were both meters. That V naught meters per second. A was meters per second squared. T was seconds, so seconds squared will give me a second squared here. And here the seconds will cancel out, leaving just behind meters. Here second squared cancels out, leaving meters. All four terms really have units of meters, so this equation is dimensionally consistent. Okay, here's another example. Let's say we had here y's in meters, b is also in meters, t's in seconds, and c's in meters per second. So we just plug in all those units. Again, I like to use these little kind of angle braces here. Meters for y, meters for b, seconds for t. C was meters per second. T was seconds, so seconds squared here for that t squared. So this term just has units of meters. This term would have units of meters times seconds. Here, one of the seconds cancels out, leaving meters times seconds. This equation makes no sense. You can't have meters equals meters times seconds. This equation is not dimensionally consistent. You would never see this equation with these units in any kind of science class. It's forbidden. It's not allowed. You can't have meters equal something that's not meters. You can't add things that are not the same. Had these turned out to be different, the equation would not make any sense. Okay, here's another good example. We all know F equals ma, Newton's second law. Force equals mass times acceleration. So let's say we're measuring the force in newtons. M, the mass, is measured in kilograms, and A, the acceleration, is measured in meters per second squared. Okay, so we get on the left side N for newtons. On the right, kilograms times meters per second squared. And you might initially think, well, that's not consistent. We don't get the same thing. But you have to remember, newtons are not fundamental units. A newton is defined to be 1 kilogram times meters per second squared. So this left-hand side really is measured in kilograms times meters per second squared, just like the right. Or we could even say the right side, when we combine these units, is measured in newtons. So this equation is dimensionally consistent. Each term has the same units. That's a good place to stop.